6 students took on the task of restoring Beaver Creek. This is the story of how they not only accomplished this task, but also reunited the community with the preservation of our cold water fishery.
Beaver Creek is located in Dayton, Virginia, about 20 minutes from campus, and it is a very active local fishery. The purpose of our project is to stabilize the stream banks, decrease erosion, and restore the riparian and in-stream habitats. We plan to restore the channel's pattern, profile, and dimensions in order to stabilize the local trout population.
Natural channel design is a design that was used to restore the stream here at Beaver Creek to a natural native design. The natural channel design was developed by Dave Rosgen, and it is a 10-step process that we followed here to mimic native streams and restore Beaver Creek. The pebble count assessment is used to assess the stream bed material. This assessment plays a major role in classifying our stream. We are physically taking 100 samples from the bottom of the stream and measuring it on a gravelometer. We don't want to see any sort of fine silt because that's starting to show characteristics of an unhealthy stream. Normal sized aggregate that's very clean is ideal for the stream and shows that it's operating healthy. The macroinvertebrate assessment is important because we need to collect data on all the different types of macroinvertebrate that are present in the stream. It is expected to find more of them in the riffle sections because they aren't getting buried by sediment, and the water's moving faster in the riffle section, so there's more oxygen for them to thrive optimally. The trout feed off of the macroinvertebrates, so it is crucial that we make sure that there is a variety of healthy macroinvertebrate present in the stream so that the trout population can flourish.
As part of our assessments, we also conducted a series of surveys, including the longitudinal profile, the cross-section, and the topographic survey. The longitudinal profile, we took points at the thalweg, the deepest part of the stream, and we used these points to determine where our riffles, runs, pools, and glides were along the stream bed. We then compared these to a healthy reference site to determine what we needed to do for our own site.
For the cross-sectional area profile, we took measurements perpendicular to the stream from one stream bank to the opposite stream bank to gather elevation changes of the channel bed itself. And like the longitudinal profile, we compared the data from our case study site to that of a healthy reference site so that we could mimic the pattern and profile in our CAD design.
The topographic survey combined points from both the cross-sectional area profile and the longitudinal profile survey, but also marked out a variety of key features throughout the stream, such as the island, the thalweg, and both banks of our stream. These points were utilized in our CAD design, which was used to create our final design.
After completing the topographic survey, we take those points and we put them into CAD. Once in CAD, we can take them and create an existing surface where we can pull cross-sections to be able to determine the stream type. After we do that, we're able to take those cross-sections and manipulate them based on our reference reaches to create a new cross-section and a new profile that we can put back into CAD to redesign our stream and create a proposed design. Once you create that proposed design and surface, we can put stream stabilization structures in, and for our case study site, we chose a rock cross vein and a lunker layer. After importing those stream stabilization structures, you can then grade the site to determine the amount of cut and fill that you will need to gently slope the surface of the stream when you're out on site.
HECRAS was a modeling tool that we used to model our proposed surface. We were able to create a terrain in the HECRAS software that showed a 3D model of our section that showed shear stress values throughout the stream where in-stream structures needed to be, and it also modeled velocity flows throughout the stream where our riffle and pool sections would be.
The Beaver Creek team implemented riparian vegetation on the left and right side of the bank. On the closest side of the water line, there would be an integral implementation of riparian plants of black willow, river locust, and river birch. On the back end of the side, 10 feet away from it, it would be implemented is the bur oak. With these implementations, it will help stabilize the stream banks and help prevent flooding and erosion on the sides. For the past 2 years, the Beaver Creek team has partnered with the 171 Child Lending Chapter. This chapter has helped us restore the stream bank at Mr. Buebeker's land. With that partnership, we had a great opportunity with the Skyline Middle School. These students learned the macro, geological, and water chemistry assessments that helped improve the stream throughout the process of this year.
After 2 years of hard work, the restoration of Beaver Creek was completed on April 21st, 2022. None of this would have been possible without the help and generosity of Chapter 171 of Tron Unlimited and the James Madison University Engineering Department. We hope that this project will continue to inspire other projects in the future so that we can continue to restore our waterways one stream at a time.